Good day, everyone. I am James Edward Mendoza from the Department of Science Education of De La Salle University. And on behalf of Mr. Cyrus T. Esguerra and Ms. Jane M. Tagapan, allow me to present to you our study entitled A Content Analysis of the Science and Engineering Practices in the Self-Learning Modules of Batangas State University Integrated School. In the school year 2019-2020, it was never expected that due to the surge of COVID-19 cases in the Philippines, the Department of Education adopted the distance learning modality in delivering instruction. This new mode of providing lessons required instruction to shift from the classroom to various means such as self-learning modules or SLMs and other video conferencing platforms. With the shift in education where SLMs now substituted textbooks, assessing them is necessary to determine their quality. And it's supported by the study of Natividad in 2021, where he found out that the quality of content and usability of SLMs enhances the effectiveness of modular distance learning. What you see now on your screens is the three-dimensional learning proposed by the National Research Council of the United States, wherein they used science and engineering practices, or the SEPs, to actively engage students in science learning. They integrated this with the disciplinary core ideas, or the DCIs, and the triple Cs, which is the cross-cutting concepts. In this study, we focus on the SEPs, wherein these are the practices that describe the behaviors that scientists engage in as they investigate and build models and theories about the natural world. It is also the key set of engineering practices that engineers use as they design and build models and systems. The NRC uses the term practices instead of skills to emphasize that engaging in scientific investigation requires not only skill, but also knowledge that is specific to each practice. For us to visualize more about the SEPs in action when it is executed inside the classroom, let's take, for example, the topic for grade 7 Earth and Space Science lesson, the Philippine environment, specifically the topic about weather. We expect them to analyze the advantages of the location of the Philippines in relation to the climate, weather, and seasons. But in the context of the SEPs, particularly in developing in them SEP number 6, constructing explanations and designing solutions, we may opt to give them a learning activity by which they will be exploring the different types of weather or climatic conditions and identify weather hazards that they experience within their respective communities. Then they will design a solution to reduce the impact of these identified weather-related hazards. And in this regard, after knowing the importance of SLMs and the SEPs in learning science, this study aimed to answer the research question, what is the level of engagement of each SEPs in the SLMs of BAT State UIS? We used the qualitative content analysis research design, which is widely used and tested method for analyzing instructional materials, and which is also in line with the purpose of the study, since it allows the identification of different SEPs as well as the levels at which they are involved in the sections of the content of the SLMs. We focused on the modules used by the senior high school department in the school year 2020-2021, wherein each module included the lesson objectives, the lesson content, learning activities, written works, and performance tasks. 8 science subjects were identified, and all of them have 8 modules in it, except for the subject disaster readiness and risk reduction, which had 7. Overall, we analyzed a total of 63 SLMs. In analyzing the contents of the SLMs, we adopted the rubric from the work of Papakonstantinou and Skoumios in 2021, which gauges the science and engineering practices in science learning materials. They named it the Science and Engineering Practices Analytic Rubric, or the SEPAR, which is a 4-level rubric that evaluates the extent at which each of the SEPs are engaged in the content of the science textbooks or any science instructional material. They initially used this in analyzing the contents of Greek physics textbooks, specifically on the topic forces in motion. Again, we adopted the same rubric in analyzing the contents of the SLMs of BAT State UIS. This is the SEPAR, the rubric we adopted in analyzing the SLMs. You see on your screens may be a little bit blurry, but later on we'll be highlighting each of the SEPs so that we will know the criteria for each level. To ensure the reliability and validity of the results, the analysis was done by two independently working researchers. The internal consistency of the two separate codings was identified for each SEP using Cronbach's alpha, which measures how reliable or consistent a set of variables are. The general rule of thumb for Cronbach's alpha is that 70% and above is good, 80% and above is better, and 90% and above is best. And as we can see, all of the coded modules for each SEPs maintain the value of more than 80%, denoting that the data is reliable. After analyzing the SEPs in the SLMs, the frequencies and percentages of the levels of engagement were identified and analyzed. And this table shows the frequencies and percentages of the levels of engagement of the 8 SEPs in the SLMs. Let's analyze each one by one. On your screen, there is a table and there is a graph. The graph is the result of the analysis, while the table that you see is the one from SEPAR. For SEP number 1, it is noticeable that 62 out of the 63 modules, or 98%, were only at level 0 to level 1 classification. This means that the majority of the modules provided little to no opportunities to ask questions or define a problem. For an instructional material to be classified at level 3, it should provide opportunities for students to ask questions that arise from examining theoretical models and in determining relationships between independent and dependent variables. It should also provide opportunities for students to evaluate a question to know whether it is testable and relevant, and if it challenges the premise of a particular argument, a data set, and or the suitability of a particular design. These factors were found lacking in the SLMs, hence the low engagement in the SEP number 1, asking questions and defining problems. For SEP number 2, majority of the SLMs provided low opportunities for students to develop and use models. Only 2% of the SLMs were able to provide opportunities for students to create and use models that are focused on predicting a phenomenon and explaining the natural world. The occurrence of the opportunities by which students will clarify the merits and limitations of the models to be used and developed were also lacking in the SLMs. The rest, although there were opportunities for students to create or use models, it was not clarified whether the models to be developed and used should focus on describing a natural phenomenon and explain the natural world, hence falling to level 1 and level 2 of the SEPAR. For SEP number 3, planning and carrying out investigations, 52 out of the 63 analyzed modules were not able to provide the students the opportunity to design or conduct investigations. Although there were some SLMs that were categorized at level 1 and level 2, specifically, they are 17%, still, they do not allow students to make decisions on experimental variables, controls, and investigational methods. For SEP number 4, the SEP of analyzing and interpreting data, significantly majority of the opportunities provided in the SLMs were classified as level 0 and level 1. Although there were some that were classified at level 2, these were opportunities that does not allow the students to decide how they will analyze the data and work with it to create representations. Still a very low level of engagement in the SEP number 4. For SEP number 5, 59 out of the 63 SLMs fell under the low level of engagement, level 0 and level 1. This signifies that majority of the SLMs provided little to no opportunities for students to use mathematical and computational skills. More so, the SLMs were not able to provide opportunities for students to make decisions about what mathematical skills and concepts to be used uh, in answering a particular scientific question. For SEP number 6, practice of constructing explanations and designing solutions, most of the occurrences fell under level 0 and level 1 of SEPAR. Most of the SLMs could not provide students with the opportunity to construct explanations and design solutions. Although there were opportunities where students would construct scientific explanations about the nature of a specific phenomena, these opportunities do not encourage the students to provide appropriate evidence and reasoning, then design solutions to identified problems. And additionally, the occurrences could not allow students to implement scientific ideas and invent multiple contrasting solutions to a specific problem. Hence, only 2% or only one of the 63 modules was classified at level 3 classification. For SEP number 7, similar to constructing explanations and designing solutions, the practice of engaging in argument from evidence, 60 out of the 63 SLMs fell under level 0 and level 1 classification. This signifies that SLMs could not provide students with opportunities to engage in student-centered argumentation, and there was no clarification that the discourse includes factual evidence, reasoning, and judgments regarding the opposing arguments. When students are equipped with basic argumentation skills, their communication skills are also developed. Hence, the SEP number 7 and its engagement to the SLMs is at low level classification. Lastly, for SEP number 8, by which students obtain, evaluate, and communicate information, 98% were on the level 0 to level 1 category. Most of the SLMs could not provide opportunities for students to obtain scientific information from texts, then evaluate this information to obtain specific scientific information. And also, these SLMs was not able to encourage students to combine or contrast from multiple sources by determining the strengths of the information obtained. Hence, still a low level of engagement of SEPs in the SLMs. In conclusion, this study investigated the level of engagement of SEPs on the SLMs of BAT State UIS, and it was found out that the majority of the SLMs fell under the low-level classification of SEPAR. This denotes the SLMs provided the students with not enough opportunities to engage in SEPs. That would be all for our presentation. Thank you so much for listening and have a nice day.